Hi grade 12s, I'm back again with another video. On this video we'll be looking at what we call functional notation. This is a subtopic that we've already covered. I'm just going to, it's basically an introduction of what we're going to cover when we start looking at your differentiation and so on and so on. So it's nothing new, it's just a revision for you, as you already covered this when you were doing functions, and you've already covered this in your previous grades. Okay, so functional notation, it has to do with representation, or symbol. And functional notation, it related to what we've already covered, which are functions. Okay, so it's a way of representing your functions graphs. If I may summarize what are functional notation, and I believe you know what are functions and how to check if a graph is a function or not by looking at your vertical line test, by looking at whether it's a one-to-many function, a one-to-one function, and so on and so on. Okay, so yeah, like I said, this is nothing new. We are just building up on what we've already covered in the previous grades. Okay, so functions, for example, let's say we've got, and this reminds me of what you did in your previous grades, maybe in your grade 8 or grade 9. We can agree that if you have a machine like this, you put there an input, you have an input, we agree that we will have what you call an output. But for you to get an output, you must have some kind of a process here. And in this case, in mathematics, or let me say in real life situation, you have what you call your raw material, and then you put this in a process, and you're gonna have what you call your product. Okay, now in mathematics we've got what we call your input, what you put in, and then this is going to depend on the formula that will be used, and you're gonna get what you call your output. Similarly, I can say if you put your x value in a formula, you're gonna get your y value. Okay, so function has two, it's a relationship between x values and y values. All right, so let's take for an example an equation, a functional equation. Is a function which is a quadratic equation. Let's say we are given y is equals to x squared minus 6x plus 8. If we were to draw this graph, we will see that it's a function. Okay, so I'm within rights to say that this y value is the same as f of x, which is something that you need to note, that when you are writing and coming back to this, if I were to say represent this in a form of a coordinate, you will say my x value will yield y value. Similarly, my x value will yield f of x, because f of x and y, they represent the same thing. It's just a way of representing them, different ways of representing them. That's why we are talking about notation. Okay, let me clear this. So we are given this functional notation. So since this is a function, we can agree that I can write it as f of x is equals to x squared minus 6x. Sorry about that. X squared minus 6x plus 8. Okay, and we are asked to determine the following. We are asked to determine a. We are asked to determine f of 0. B. We are asked to determine f of minus 1. C. We are asked to determine f of a. D. We are asked to determine f of x minus 1. And lastly, E. We are asked to determine f of x plus h. Okay, like I said, grade 12s, here it's just a matter of substitution. It's nothing new, it's already what we've covered, but it's important for me to start explaining what's happening here before we get into the real stuff. Okay, so when you start your A, you're gonna say, okay, I'm given an equation, I'm given a function, and this is my function. It says f of x is equals to x squared minus 6x plus 8. Now what will be f of a of 0? F of 0 will mean that I have 0 there squared minus 6 times 0 plus 8. This will give me 0 minus 0 plus 8, which will give me 8. So if I may represent this, if I were to represent this in a coordinate form, I will say my x value is 0 and it gives me a y value of 8. Okay, nothing new there. B, I'm given f of x is equals to x squared minus 6x plus 8. I want to determine, or I'm asked to determine f of minus 1. This means that where I see x, I put minus 1. So this will be minus 1 squared minus 6 into minus 1 plus 8. This will give me negative 1 squared is the same as 1. 1 negative times negative is positive. 6 times 1 is 6 plus 8. Therefore, 7 plus 8 is equals to 15. Is equals to 15. So if I were to represent this in a coordinate, it will be x is minus 1 and 15. Okay, let's move to C. C, I'm given that f of x is equals to x squared minus 6x plus 8. I'm asked to determine what is f of a. F of a. What does this mean? It means where I see x, I just substitute a. So there's nothing new here, and all I have to do is say a is squared minus 6a plus 8. I can't simplify this any further. So my coordinates will be, when my x is a, my y value is a squared minus 6a plus 8. Okay. D, it says I'm given that f of x is equals to x squared minus 6x plus 8. Now I have to determine f of x minus 1. This grade 12 is what we call a package. It's a package. These two are attached, you can't separate them. So what does this mean? It means that I do the same thing, it's just a matter of checking what I need to substitute. In this case, my x is not x, it's not negative 1, but it is x minus 1 squared minus 6 into x minus 1 plus 8. Now I simplify this. This will be the same as x squared minus 2x plus 1. This will give me minus 6x plus 6 plus 8. If I simplify this and correct all the like terms, x squared minus 2x minus 6x will give me minus 8x. 1 plus 6 is 7. 7 plus 8 is 15. So my coordinates for this will give me, what's happening with this pen? Will give me my x value is x minus 1. My y value is x squared minus 8x plus 15. Okay. Well, let me erase this side. Lastly, I'm given that f of x is equals to x squared minus 6x plus 8. I'm asked to determine f of x plus h. And this is the most important one, because when you start doing your limits and your rules of differentiation, or basically looking at your first principle, this is what you're gonna get. So you must be confident and be able to solve this while we are still at this early stage. So as I said, this is a package. This is a package. So it means that where I see x, I put x plus h squared. Minus 6, where I see x, I put x plus h. And this will be plus 8. If you simplify this, you'll find that it will give you x squared plus 2xh plus h squared minus 6x minus 6h plus 8. And then, are there any like terms here? There are no like terms. So it means my coordinate will be x plus h, and my y coordinate will be x squared plus 2xh plus h squared minus 6x minus 6h plus 8. I know that looks a bit scary, but that's a way of writing it. This, because we don't have the values for x and h. So yes, grade 12s, in a nutshell, that is what functional notation is all about. You just look at the function that is given, you check what they want you to determine, you substitute where you see your x, you simplify until you get to the last step. So yeah, until we meet again, I hope you enjoyed the video. Make sure that you catch up and wait for another video where I'll be discussing your next subtopic, which will be average gradient. So see you next time. Thank you.